Hi, welcome to my channel. Today we will talk about Azure Container Apps. This is part 1 of the series about that topic. In this episode we will focus on architecture overview. Let's go! First, we will see what the Container Apps is all about. Then we will talk about environments, external versus internal. Then we will deploy sample infrastructure when we can show a demo. Then we will talk about load balancing options, where we will talk about ingress, HTTPS ingress versus FrontDoor, Tier Standard or Premium. Azure Container Apps is a platform that allows developers to create serverless microservices by leveraging containers. This solution is specifically designed to run general-purpose containers, making it ideal for applications that use multiple microservices deployed in containers. To provide additional functionality, Container Apps is powered by open-source technologies, such as Kubernetes, which is run underneath the Azure Container Apps, DAP, which means the Distributed Application Runtime, which provides API that simplify microservices connections. So whenever you want to communicate between the services with the pattern like invocation or publish supply messaging, then DAP can help us. Next is KEDA. KEDA is the Kubernetes-based event-driven autoscaler. With KEDA, you can drive the scaling of any container in Kubernetes based on the number of events needing to be processed. We will need that in the next episodes when we will want to scale our containers based on CPU, memory, or HTTP requests. Next, Envoy is a high-performance distributed proxy designed for single services and application, as well as communication bus, and a universal data plane designed for large microservices. Azure Container Apps uses Envoy as a network proxy. Network requests are proxied in the Azure Container Apps to achieve the following capabilities: allow apps to scale to 0. Running instances are required for direct calls to an application. If an app scales to 0, then the direct request would fail. With proxying, Azure Container Apps ensure calls to an app have running instances to resolve the request. Achieve load balancing. As requests come into Azure Container Apps, applied load balancing rules spread requests across container replicas. Azure Container Apps support Kubernetes-style apps and microservices, including features like service discovery and traffic splitting. Additionally, Container Apps enables event-driven architecture through its ability to scale based on traffic and pull from event sources like queues, and event support scaling down to 0, as we just talked about. Finally, Container Apps offers support for long-running processes and background tasks. We can have external or internal environment where we can deploy our applications. Container Apps environment deployed as an external resource are available for public requests. External environments are deployed with virtual IP on an external public-facing IP address. On the other hand, internal Container Apps environments is deployed as internal resource and has no public endpoint. Internal environments are deployed with virtual IP mapped to an internal IP address. The internal endpoint is Azure Internal Load Balancer, and IP addresses are issued from the custom VNet list of private IP addresses. Here is the simple architecture, what we will build in the future episodes. Today we will focus on this one, so the external container app environment. We'll deploy network security group. We'll deploy our virtual network, and in that network we will deploy the container apps environment. When we will set the external, we will have load balancer with a public IP. So if we want to send requests to our app, we just can use the container apps ingress, HTTP ingress, or we can use FrontDoor Standard in that setup. As an outbound traffic, we will deploy our route table, but for now, we cannot use the firewall since it will be available around April, but we can route our traffic to the Azure network. And later, in the next episodes, we will deploy other resources. On the other hand, the internal, as we mentioned, has internal load balancer. So the options that we have, we can create a private link, and we can use FrontDoor Premium or Application Gateway. In the demo later, we will deploy FrontDoor Premium, which will be linked with our VNet with private link. So we can send our requests to the internal application. So as we mentioned in the last slide, we can have ingress and the front door. So Azure Container Apps supports two types of ingresses, HTTPS and TCP. With HTTPS ingress enabled, container apps have following characteristics, as you can see here. So in that regards, we do not have to deploy any other resource. But if we want, we can deploy the front door, which is an application delivery network that provides global load balancing and site acceleration service. And we have available two tiers like standard and premium. Premium, the difference between that tiers is that premium have support for private links and also has additional features for the firewall rules. Costs. So Azure Container Apps billing consists of two types of charges. So it's resource consumption and HTTP request consumptions. You can check the exact costs when you will follow to the Microsoft calculator, where you can check all the options by yourself. Now it's time for short demo. If you want to follow along, this is the requirements. This is the link to the repository with the code, which I will link in the description. Let's jump into the Visual Studio Code to check what we will deploy. First, we will deploy the external environment. The first resource is the route table. As I mentioned before, right now we cannot send the outbound traffic through the firewall. Next, we'll deploy network security group. We need to allow two ports into our VNet, which is 80 and 443. Next, we'll create a virtual network with one subnet, and this subnet will belong to the container apps. So we attach the network security group and we attach route table to that subnet. Then we'll create the log analytics and also application insights. And here's the definition of our container apps environment. So we'll deploy it in our VNet, and we will set that this environment is external. We also will not use the zone redundancy. Next, we will create managed identity and the container app. For purpose of this demo, I will just use Hello World container image from Microsoft. And right now, let's check the internal setup. Route table, network security group, virtual network is almost the same. The difference is that this time you want to create the private link to the front door. So we need to add these two options. So we need to disable network policies. Log analytics, application insights is the same. The difference in the container app environments is that we need to provide the Boolean value for the internal. So we'll let them know that this environment needs to be internal. Next, we will create the private link service. I wrote the module for that. So we'll just pass the subnet and the value for the load balancer, which we know that is created. I will show you in the Azure Portal why this name is set. And at the end, we'll deploy the same image for our application just for purpose of testing. One thing I want to mention about external environment, that we have the option to secure to add the IP restriction in the ingress of our application. It may be useful if you want to use the FrontDoor Standard. So we can add here the IP ranges of our front door. So we will be able to access our application only through FrontDoor and not with direct access to the ingress. So this is very useful if you want to route the traffic from one source. As for now, we have to add the IP addresses ranges by ourselves. We cannot use service stacks, but we can download the IPs of the Azure FrontDoor backend from the Microsoft websites. This is the IP ranges of the Azure FrontDoor, and we can add this value to these parameters as a list of IP ranges. Right now, let's jump into the Azure Portal for the rest of the demonstration. Okay, we managed to deploy these two resource groups. In one resource group, we will have the external environment, and in the second group, we will have the internal environment. As you can see, when we deploy the application, when we will deploy the Azure Container Apps, also two additional resource groups are created for the Kubernetes resources. Let's check them. As you can see, this is the resource group for the internal environment. And as we spoke about the private link, here is the name of the load balancer, internal load balancer. So that's why we use that name, since Azure set that name as the default value. And this is the Kubernetes resource group for the external environment. As you can see, we have public IP addresses here and no internal load balancer. Right now, let's go to the external resource group. So as you can see, here's our resources. This is the container app environment. And we have one container app here. Let's go to that app. Let's go to ingress. As you can see, as this is external environment, we accept traffic from anywhere. And this is the IP restriction feature which are in preview, but as I mentioned, we can add the IP ranges of the front door after we will deploy it. This is the endpoint. Let's check it. As you can see, we managed to open the site, so the connection is working. For the purpose of this demonstration, right now, let's set up the FrontDoor Standard as an additional resource. Let's give it the name Standard. The tier will be Standard. We will not add anything to secrets, but we will create our endpoint. Okay, let's add routes. Here we will not change anything, but we will add the new origin group. So let's give that name and let's add origin. Here will be custom. Let's add it. Okay, the rest we will leave the same. Review and create. Our standard front door is created. Let's go to the resource and here is the hostname. Let's copy this hostname and we are able to connect to our container apps with the FrontDoor Standard setup. Okay, let's close this. Let's go back to home and let's go back to the resource groups. And right now, let's test the internal load balancer setup. Everything is the same, except that we also created the private link service. Private link service connection. Right now, there are no connections, but in the moment, we will create the premium front door. Let's go to the container app. Let's go to ingress. And here is our endpoint. Let's see if we can connect. As you can see, as this is the internal environment, we are not able to connect. But fear not, let's create the premium front door. Let's give it the name. This option is not cheap. It's around $300. So you can for sure use it in the production environment, especially for the enterprise customers. Let's add endpoint. Right now, let's add root. And let's add origin group and origin. Let's set up the custom. Let's copy the address of our container app. And right now we'll enable private link service. As we already created this service, here it appears. And let's give a message. Review and create, and we will be right back when it's created. Our premium front door is created. Let's copy the address and let's see if we will be able to connect. Okay, we are not able to connect. What is wrong? One thing, we need to enable private link service. So this is something that we need to remember. If you stumble upon that error, you need to remember that we need to approve this connection. So let's approve it. Okay, our endpoint is approved. Let's go back to our resource group, internal. Let's go back to our front door. Okay, we managed to connect through our FrontDoor Premium to our Azure Container App instance. Thank you for watching. Stay tuned for the next episode according Azure Container Apps. If you have any questions, just let me know in the comments below that film. I will also link all the materials in the description of that episode. And here I will also link films that you may find interested. Thank you and see you in the next episode. Bye.